Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Cyclopentanone reacts with HCN, nucleophilic addition, to give a cyanohydrin 1-cyanocyclopentane-1-ol, compound A. The CN group adds to the carbonyl carbon, giving a tertiary alcohol with a CN substituent at what was the carbonyl carbon of cyclopentanone. Moving on to the next step. The cyanohydrin 1-hydroxycyclopentane-1-carbonitrile is reduced with Lyell-4. Lyell-4 reduces the CN group to CH2NH2, and also the OH remains. It is not reduced under these conditions since it is already an alcohol. So compound B is 1-aminomethyl cyclopentane 1-ol, i.e., the cyclopentane ring bearing both an OH and a CH2NH2 group at C1. And for the final step, B, a primary amine, CH2NH2, reacts with nano to HCl, diazotization conditions for primary aliphatic amine. Primary aliphatic amines treated with nano to HCl form unstable diazonium salts that immediately decompose. The CH2NH2 group becomes CH2N2+, which loses N2 to form a carbocation carbenium ion, CH2+. This primary carbocation rearranges. The ring expands as a C to C bond from the cyclopentane migrates to the adjacent carbocation center, giving a 6-membered ring carbocation, cyclohexyl cation at the carbonyl equivalent position. The OH group at the tertiary center assists. The whole process is a ring expansion. Specifically, the 1-aminomethyl cyclopentane 1-ol undergoes deamination with ring expansion. The cyclopentane ring expands to a cyclohexanone ring. The tertiary carbinolamine system loses N2 and the hydroxyl group, with ring expansion yielding cyclohexanone. Mechanism detail. After loss of N2 from CH to N2+, the resulting CH2+, primary carbocation, is adjacent to the ring carbon-bearing OH. A1, 2 shift of the C1, C2 bond of the cyclopentane ring into the carbocation gives a 6-membered ring with an oxocarbenium ion, or the OH at the former C1 becomes a ketone after loss of H+. The net result is ring expansion from cyclopentanone, 5-membered, to cyclohexanone, 6-membered. Why other options fail? B, 2-methylcyclopentane 1-1 and C, 3-methylcyclopentane 1-1, these would require methyl substitution without ring expansion, which is not the outcome of this sequence. D, 1-hydroxymethyl cyclopentane 1-ol, this would be compound B after Lyell-4 reduction if we consider CnCH2O, but Lyell-4 reduces Cn to CH2NH2, not CH2O. Moreover, product C requires the nano to HCl step, which causes ring expansion. Therefore, the correct answer is A. Therefore, the correct answer is option A.